US Physics Olympiad, year 2011, F equal MA, first round. Problem number 23. Solution for this problem you can find below this video on the description reference. A particle is launched from the surface of a uniform stationary spherical planet at an angle to the vertical. The particle travels in the absence of air resistance and eventually falls back onto the planet. Spaceman Fred describes the path of the particle as a parabola using the laws of projectile motion. Spacewoman Kate recalls from Kepler's laws that every bound orbit around the point mass is an ellipse or circle, and that the gravitation due to a uniform sphere is identical to that of a point mass. Which of the following best explains the discrepancy? Solution. First, let's check that we have uniform stationary spherical planet. It means that in any case this planet could be replaced by a point mass in the center of this planet, and any particle could have either elliptical, either parabolic or hyperbolic trajectory around this planet. So that's the case. Now, when we know what is the case, we can check all 5 answers. Answer A. Because the experiment takes place very close to the surface of the sphere, it is no longer valid to replace the sphere with a point mass. Obviously, this is not true. B. Because the particle strikes the ground, it is not in orbit of the planet and therefore can follow a non-elliptical path. That's not true because before it strikes the surface of planet, it's going by elliptical orbit. It cannot be hyperbolic or parabolic. In that case, a particle will never return back if it's going from a surface under some kind of angle. So that's not true either. C. Kate disregarded the fact that the motions around the planet mass may also be parabolas or hyperbolas. That's not true. We know that any orbit could be elliptical, parabolic or hyperbolic. D. Kepler's laws only hold in the limit of large orbits. Again, that's not true, because it doesn't matter what kind of orbit we have. Kepler's laws, they are always correct in case of point mass. And answer E. The path is an ellipse, but is very close to a parabola due to the short length of the flight relative to the distance from the center of the planet. That's correct answer. Because particle returned back to the surface, that's an ellipse, but because this trajectory is very close to surface, we can say that it's very close to parabola due to uniform gravity around this surface. So correct answer is E. US Physics Olympiad, year 2011, F equal MA, first round. Problem number 24. Solution for this problem you can find below this video in the description reference. A turntable is supported on a Teflon ring of inner radius r and outer radius r plus delta. Delta much less than r, as shown in the diagram. To rotate the turntable at a constant rate, power must be supplied to overcome friction. The manufacturer of the turntable wishes to reduce the power required without changing the rotation rate, the weight of the turntable, or the coefficient of friction of the Teflon surface. Engineers propose two solutions: increasing the width of the bearing, increasing delta, or increasing the radius, increasing r. What are the effects of these proposed changes? Solution. First, let's write equation for power. Power equal force of friction multiplied by radius and multiplied by angular speed. In our case, force of friction we cannot change, because weight of this table will not change and the coefficient of friction will not changing. So it means that only a change of radius r can affect this power. And if we investigate all 5 cases, only in case A we have correct answer. So that's the solution A. Problem number 25. Solution for this problem you can find below this video in the reference in the description. A hollow cylinder with a very thin wall, like a toilet paper tube, and the block are placed at rest at the top of a plane with inclination theta above the horizontal. The cylinder rolls down the plane without slipping, and the block slides down the plane. It is found that both objects reach the bottom of the plane simultaneously. What is the coefficient of kinetic friction between the block and the plane? Solution. First, let's draw this picture. We have block which is going with the friction, and we have hollow cylinder which is rolling without sliding. So for both cases we can write Newton equations. For block we have equation ma equal mg sine theta, which is part of horizontal force of gravity. Horizontal means going down the hill, and minus force of friction, which is mu mg cosine theta. And from here we can find that acceleration equals this expression. For a rolling cylinder we have these two equations. The first equation, that's translational motion for cylinder, that's ma equal mg sine theta, where mg sine theta, that's force of gravity in the direction of this incline, minus force of friction. And the other equation is for rolling. We have I alpha equal force of friction multiplied by radius, which is torque. And from here we can find that I for hollow cylinder equal mr square, and alpha equal acceleration over radius, because it is going without sliding. And when we insert this expression to this second equation, we have force of friction F equal ma. Now we can put this to the first expression and find that acceleration equal this expression for hollow cylinder. And now, because both objects they are reaching bottom for the same time, we have both acceleration must be equal to each other. So this acceleration equals this acceleration. And from here, total coefficient of friction must be equal to 1/2 tangent theta, which is answer C.